All right. So for example 5.2, we know that there is a crate that has 40 kilograms. We're told from our textbook that a guy is going to pull on it at an angle of 30 degrees and that he's going to displace it 7 meters. We also know that the coefficient of friction for kinetic friction is 0.55. We're asked one question: how much work is being done? Well, we know that work is equal to, so let me draw my guy pulling this. We know that work being done is the force, or the sum of forces, parallel to the displacement times the displacement. So what's the first thing I need to do?
Find out what forces are parallel to the displacement.
Find out what forces are parallel to the displacement. Does anybody have any ideas how I might go about doing that? Yes?
Look at the ones that go up and down.
I want to draw a free body diagram.
Okay, so let's draw a free body diagram. And I'm going to take a little more time on drawing this free body diagram. All right, so we want to figure out the x and y plane and what forces. Now, what's parallel to the displacement? The x plane or the y plane?
Y.
Parallel.
No, X.
X's, right? So I'm just going to start writing things down. So somebody shout out a force that's acting on this. Huh?
Normal.
The normal force. Okay, so the normal force goes up. So the normal force is that way. There's a force due to gravity, which is usually down. Right, so that would be the weight of the object, which is equal to mg in the down direction. What's another force acting on this?
Friction.
Friction. Which way does the friction go? Friction's going to go to the left, right? So we'll have a frictional force. Now the frictional force, what's the formula for that?
Coefficient of friction times
Mm-hmm. All right. What else? What other force is acting on it? The guy, right? So the guy's going to have a force too, and that force is this. Do we know what that force is?
Nope.
So this is going to be like force applied. Is there any other information I need to list? The force applied has an angle of 30 degrees. Now, probably I need to break that up into components, right? So now how do I break that up into components? I have the x component, which goes this way. And how do I calculate that? F cosine of 30, right? And then what's the other component? In the y direction, which is f sine of 30. So what I need to do is I need to sum these up. So what I want to do is I want to say, what are all the forces acting in the x direction? Well, I have f of cosine of 30. Do I know what f is yet? Nope. And what is, so, and that's the positive x direction, and this is the negative. And then I also have, it looks like the frictional one, which is f of this. And I put a negative because that's going in the opposite direction. Are you guys with me so far? Now, I could rewrite that as f of cosine 30 degrees minus we said mu k times the normal, right? Now that's the total force times the mass times the acceleration. So this is really equal to the mass of the object times the acceleration in the x direction. Now just before this object starts to move, we would say that that is equal to 0. Okay? In other words, we would say that the mass times the acceleration in the x direction is equal to cosine of 30 minus mu k times the normal force is equal to 0 in the x direction. Because if it's accelerating at a constant velocity, and that was one of the clues I forgot to say at the beginning, if it's accelerating at a constant velocity, well, I can't even say the word. Do you hear the error in the sentence that I'm saying? In the textbook, when you read it out of the textbook, it says that it was moving at a constant velocity and he was applying a force. So if he's applying a force, but it's moving at a constant velocity, that means the velocity doesn't change. So that means that the acceleration of the mass is what? 0. So what we find is when we set this equal to 0, what we find is that f cosine of 30 degrees is actually equal to mu sub k times the normal, right? If I just look at this and subtract mu sub k from both sides, I'll get that. Now we really need to put our thinking caps on. I'm going to pause right here and ask you guys, do you have any questions so far? Okay. Now, for the normal force is the force that's applied to the object to prevent it from going down. What's causing it to go down? The force due to gravity. So what I need to do is I need to sum up the forces in the y direction to kind of figure out what the normal force is. Because it might not just be mg. So to sum up the normal forces, what I need to, or the forces in the y direction, I know that I have the normal, and then I can't forget about this. So the normal is going up, right? Plus, I have this f of sine of theta of 30 degrees. That's pushing up too. And then I have the weight of the object, which is minus mg. Now, since it's not accelerating up or down, that's equal to the mass times the acceleration, so that's set equal to 0. So if I solve for the normal, and I move everything else to the other side of the equal sign, I get that the normal is equal to the mass times this acceleration due to gravity minus f sine of 30 degrees. Does that make sense? I'm going to pause right there and I'll say it in plain English without the sum of the forces in the y direction. This crate is not moving up or down. But I have a normal force. I have the vertical component of the guy pulling on the rope at an angle. That vertical component and the normal force are going upwards. Then I have the force pulling downwards due to gravity. Okay? You guys with me on that so far? So then what am I going to do? Well, then that is not accelerating up or down. So the mass times the acceleration, because there's no change in position, which means there's no velocity. If there's no change in velocity in the vertical direction, then there's no acceleration. So all this stuff is equal to 0. So then algebraically, I could solve this and make it equal n to find the normal force. Does that make sense? So then we see that the normal force is all this stuff. So now what I need to do is I really need to find the force in the x direction And to find the force in the x direction, or the sum of the forces in the x direction, what I really have is I have all this stuff. I have this line here. Are you guys with me so far? So I'm going to rewrite that line, and I'm going to say the force cosine of 30, the force times the cosine of 30 minus mu k times the normal, but we just said that the normal is all of this stuff, didn't we? So I'm going to say the normal of this stuff, which is really this. And all of that has to equal 0 because this whole object is moving at a constant velocity, which means the acceleration is equal to 0, correct? Are you guys with me so far? Does anybody have any questions at this point?
You lost me.
On what?
Past Fy equals n, like past the point where everything equals 0, everything past that started like blur together for me. I don't know.
Okay, so let's do a brief recap of where we're at and how we got there. Got a crate moving at a constant velocity. The crate has a mass of 40 kilograms. There's a guy pulling on the rope 30 degrees above the horizon. He's pulling with a constant force. We don't know what the force is. He displaces the object 7 meters. Now, to find the work, because that's what the textbook is asking, we need to figure out what the force is parallel to the displacement, which is the force in the x direction. So then we've got to figure out all these forces. So to find all the forces, we draw a free body diagram. I think you guys are good on what the free body diagram is. But now what we've got to do is we've got to figure out the force in the x direction and the force in the y direction. And then once we figure out what the net force is in the x direction, we can plug it into the formula, multiply it by the displacement, and get the work. So the way that we do that is we take the free body diagram and we say, what are all the forces in the x direction? Well, we have a positive force, which is f of cosine of 30, or f times cosine of 30. And then we have an opposing force, which is the force due to friction, which is in the opposite direction of the motion. So we go, these two forces equal this. But that force is also equal to the force of the object, which has a mass times the acceleration, but since we said the object has a constant velocity, that means there's no acceleration of the object. Does that make sense? So this, which is equal to the mass times the acceleration of the object, which is equal to 0. So I'm going to pause right there. Are we good? Do we see how the force, the applied force, times cosine of 30 minus mu sub k times the normal force equals 0? If not, raise your hand. Let me know. That's why we're doing this. Yes?
I just don't. Instead of raise your hand if you don't get it, I just raise
Okay,
your
so
hand.
what is it that you don't get? So here's what we'll do is we'll start right here. I'm going to add all the forces only in the x direction.
That I get.
Okay, so this force is F times cosine of 30, which is the component force of the applied force.
Not that.
That's going in the positive direction. Now, I have a force due to friction, which is the coefficient of friction, times the normal force. Yeah? Does that make sense?
Yeah.
Okay, but that's going in the negative direction, so we're going to subtract it, right?
Okay.
Okay, now, the object is not changing its velocity, and by definition, the acceleration of an object is a change in velocity. Since it's traveling at a constant velocity, what is it accelerating?
0.
0. So this minus this has to equal 0.
Okay.
Does that make sense?
Yeah.
Now, algebraically, what I could do is I can subtract or add mu sub k n to both sides of the equation, and I'll get this as an equation. This equals this. We might use that later on. Because really, what I need to do is I need a force in the parallel to the displacement times the displacement. So we're trying to figure out what that force is. And we don't know yet. So now the next step because I need to know what the normal force is, I need to sum up all the forces in the y direction. So I'm only going to focus on all the forces in the y direction. So what's the first force in the y direction? The normal force. I don't know what it is yet. Then I have the vertical component of the applied force, because when he pulls the rope at an angle, the rope pulls the object up and it pulls it to the side. Well, to figure out what that is, I have to say F times sine of 30. Are we good on that so far? All right, good. So now, the only other thing that acts on it is the weight of the object, or force due to gravity, that accelerates at 9.8 meters per second squared, which is g. We call that g. But that's going in the negative y direction. So I say the sum of the forces is the normal plus F times the sine of 30 minus mg. But since the crate isn't moving in the up or down direction, then the acceleration is 0. So n plus F times sine of 30 minus mg equals 0. Now if I take that equation, if I take these two things, I can algebraically solve for the normal, which is what I need to plug in here. So what I'm doing all this work because I want to know what the normal is. And so I've solved for the normal. Are you guys with me so far? Does that make sense? Does it help that I've explained it a second time? Because sometimes we need to go over it 2-3 times. So if you have a question, I don't care if you ask. That's how we learn. If I keep going on with the problem and you're not quite sure, it's just going to be confusing. So I don't mind taking our time and answering questions at this point. Yes?
So, after that, how did you get to the step to combine them? That's what I'm confused about. Is there equals F cosine of 30 times minus K?
Oh, okay. So now this, you don't see it, but this equation right here, see this? That's this. I'm trying to figure out, remember, we need to figure out the forces in the x direction, because the displacement is in the x direction. So I know that the force is in the x direction, which is F cosine of 30 minus the frictional force, which is this here. But I know that the normal force is mg minus, so this line is this line, except I'm substituting in for the normal force, mg minus F sine of 30. Does that make sense? All right. So what I'm really trying to do is I'm really trying to figure out what F is. Because that's what I need to know. I can't do anything else until I can figure out what F is. Okay. So then what I want to do is I want to take this and solve it for F. Okay? So what I do is I say, all right, let's separate this stuff. I'm going to have 0 is equal to F cosine of 30 minus mu k, and I'm going to distribute the mu k through. mg plus mu k F sine of 30. You guys with me so far on this? Do you see what I've done so far? So now the next step is to do what? Remember, I'm trying to figure out what F is. So I gotta get all the terms with F on one side and all the other terms on the other. So now if I just subtract or add mu k mg to both sides, I get mu k mg is equal to F cosine of 30 plus mu k F sine of 30. Now what I want to do is factor out an F. So if I factor out an F, I get cosine of 30, right? Plus mu k of sine of 30, or times sine of 30. Is that right? I had an f here and an f here if I factor it out. So now what do I got to do to solve for f? Well, I've got, if I divide both sides by this stuff, I get mu k mg all over cosine of 30 plus mu sub k sine of 30. That equals my force. Well, those are numbers. I've got numbers I could plug in for all this stuff. So I could say 0.550 times 40 kilograms times 9.8 meters per second squared. Does anybody know what cosine of 30 is if you approximate it as a decimal? This guy does. It's 0.866 plus 0.55 times sine of 30, which is 1/2. All that equals 189 newtons. So we did all that math, do you know what for? To figure out that the force that this guy applies is going to be 189 newtons. Did we figure out the work yet?
No.
Good Lord, no, we didn't figure out the work yet. But what do we know the formula for work that's parallel to the displacement? It is the force times cosine of 30 degrees times the displacement. So how do I figure out the work done on this object? I'm going to say the work is equal to 189 times cosine of 30 times 7 meters. What does that equal? The work. So I'm running out of space here. Maybe I should write it on a separate sheet of paper, or are you guys okay if I squeeze it in down here?
Squeeze it in, save the tree.
I'll write it right here. It's 1.15 times 10 to the 3 joules. Does that make sense? And just to prove it to you, I'm going to add it all. I'm going to multiply it all up here. So we said 189 times the cosine, right, of 30, and the cosine of 30 we said was 0.866 times 7 meters, wha-bam, with the bacon sizzle, it's 1 point, and if you round and use sig figs and then use scientific notation, that's the answer you'll get. You'll get 1.15 times 10 to the 3rd joules. Yes?
I did not get 8.66 for cosine of 30.
You're not in degree mode.
Oh.
You're in radian mode. So if you switch that around, that'll take care of that.